Go. This is a continuation of 3.6, solving quadratics by completing the square. So we're following the steps from the notes, and this is a similar question to the ones that you've seen so far. So in the first couple questions, the lead coefficient is 1, so we don't need to factor. We do need to isolate the C value, so we're going to subtract 63 from both sides. So k squared minus 16k, and then we put the plus blank, equals negative 63. To figure out what goes in this blank, we take our b term and divide by 2 and square it, which is negative 8 squared, which is 64. Adding 64 to one side, we also add it to the other side. So we have k squared minus 16k plus 64 equals 1. And then the next step is to write our perfect square trinomial. Notice this is a perfect square, this is a perfect square, this is 2ab. We can rewrite this as k, there's a minus sign, so it has to be a minus, 8 being the square root of 64. Also notice this is the same, you can look at either spot, equals 1. And finally, we take the square root of both sides, k minus 8 equals plus or minus 1. Add 8 to both sides. So we get k equals, we got the positive 1 plus 8 and then the negative 1 plus 8. So we have, keeping in mind the plus and minus, and that's 9 and 7. So our two solutions are 9 and 7. So that was a review question. I can do one more of those. We have n squared minus 12n minus 66 equals 0. Isolate the c value, adding it to both sides. Take the b value, divide by 2 and square it. So adding 36 to both sides. We got the 12, 102 here. Perfect square trinomial again. So this is going to be n minus 6 squared. Now we square root both sides. And in this case, 102 can't actually be simplified. We do want our answers as exact values. And remember, that means in radical form. If we estimate as decimal form, that's no longer exact. So be sure to keep your answers in radical form. So now we have n minus 6 equals plus or minus square root of 102. Adding 6 to both sides, we get n equals 6 plus or minus radical 102.